Good evening, everybody, and welcome to Getting Started with Intel Galileo Maker Sessions. My name is Matt Richardson. I'm a contributing editor for Make Magazine, and if you're new to Getting Started with Intel Galileo Maker Sessions, welcome. This is a 3-week program that's a partnership between Make Magazine and Intel, all about getting teams of makers across the globe to make projects with Intel Galileo. Intel Galileo is Intel's brand new Arduino compatible board that has an Intel chip on it, and we're really excited to be making things with it. And we equipped 40 teams across the globe with kits that include the Galileo, include components to make with Galileo, and a copy of my upcoming book, Getting Started with Intel Galileo. There's a wonderful Google Plus community that I'm sure some of you have already visited that you can ask questions and show off your work and communicate with other teams. And even if you're not a team, we encourage you to join in there. And also tonight during this Hangout, please ask your questions in the Google Plus community and we'll try to get to them while we're doing the Hangout. These Hangouts happen on Thursday nights during the program, and they will feature master makers. And with that, I'd like to introduce our master makers. First of all, starting on the left, we have Clay. Hey, Clay. Hey, have you muted yourself there? Or are you...
That better?
There we go. Hey, Clay, how you doing?
Hi, I'm Clay. I'm a former engineer with Intel, recently retired, and I've been making and tinkering my whole life, and I'm excited about Galileo and have done a few projects with it now, and I'm excited to be here.
And I see some stuff behind you that I think we'll get a chance to talk about in a little bit. Great. I want to jump over and introduce Michael. Hi, Michael.
Hi, Matt. Michael Hart here. I'm sitting right next to Clay, my former colleague as of Friday. I'm a current unretired Intel employee, I'm sorry to say. Well, I'm unretired. That's the sad part. But I'm happy to be here and excited to see my professional life joining up with my passion for Arduino. So good to be here.
Great. Thanks for being here. And then we also have Tyler. Hey, Tyler.
Hi, I'm Tyler. I'm a software developer out of Ann Arbor, Michigan. I've been playing with Arduino for 5 or 6 years and really love creating network devices. I got excited about the Galileo because it combined the network interfaces right on board and lots of room for expansion. So I've been moving a bunch of my projects over from Arduino to Galileo.
Good. Well, I am looking forward to talking about that. And as I mentioned, we have teams of makers across the globe. We've got one team joining us tonight in the Hangout. We've got Hal and Luis. Hey, guys.
Hey, how are you?
Hey. Good, good. What's going on there?
So we're at the Maker Studio in Kansas City. We're in a science center called Science City, and we're inside of a 100-year-old train station. And Hal Godfrey is my Arduino mentor, so that's why he's here. But we're excited to see how we can incorporate it into the makerspace and also into the Science Center, so possibly monitoring exhibits or creating exhibits.
That's great. Fantastic. Well, thanks for being here. And if you guys have... I know you guys are really just starting to work with Galileo, so if you guys have any questions as we're talking, jump right in there. We'll do the best to answer. You know, I think all of us are really Galileo beginners because it's such a new board. So we're trying to help each other out and figure out, and there's so many resources like the Google Plus community and Intel's community where we're all getting answers and figuring things out and helping each other out. So thank you guys for being here. We appreciate it a lot.
Thanks for having us.
Thanks.
So I want to start with what you guys have been working on and what you've done so far with Galileo. I want to start with Clay because I see the draw bot behind you, and I'm just dying to hear more about it, and I want to show everybody what's going on there. So what do you got behind you?
So it's a Galileo. Let me see if I can move my camera so you can actually see the parts. So there's a Galileo and 2 stepper motor controllers from SparkFun. And it is hooked up to the stepper motors up at the top that drive little spools, and then the pen mechanism with a servo to pick up and down the pen. And you can see some of the artwork that it's done, and you can see that some of my math for the coordinate transformations not quite right yet, but it's a work in progress, and I thought it would be interesting to show. My goal is to set it up so that it is taking all of its print information wirelessly over the network and drawing on the whiteboard, and I plan to build a 4-pin station for it so I can do colors and all that jazz.
Could you talk a little bit about what a stepper motor is and how that's different from any other kind of motor someone might find?
Sure. So stepper motors have individual coils that are wired out separately. In a normal DC motor or a universal motor, there are brushes that rub on the center shaft of the motor so that as it rotates, it switches the direction the electricity goes through the coils of the motor, which reverses the magnetism, which makes the motor want to turn further, which causes it to switch again, which causes it to want to turn further. And that's how a normal DC motor works. A stepper motor, instead, the magnets on the shaft are permanent, and then the magnets in the casing are, the electromagnets in the casing are wired out individually. So by energizing them in the right sequence, you can make the motor step individual positions as it goes around, and you can control how frequently it does that. And when you aren't changing which magnets are on, the motor is held firmly in the position it's in. So if you're trying to do motion things, stepper motors are often the best choice because you can have the stepper motor step some number of steps and it'll stop when it gets to the other end and it'll stay there. Whereas a DC motor, if it has power, it's going to try to rotate, and if it doesn't have power, then it will turn if there's anything trying to make it turn, whereas the stepper will hold position.
Now, when you use the stepper motors with Galileo, you mentioned you had these SparkFun driver boards. Can you talk about how they work and how Galileo uses them to control the steppers?
Sure. So the stepper motors, the coils use more power than the Galileo or any microcontroller can output on a pin. And so you need some kind of amplification of the power in order to energize, to have enough energy to make the coils magnetic enough to make the motor turn. I use a fairly advanced stepper motor controller, and there's a variety of them out there. The one I use is from SparkFun, and it basically takes two signals from the Galileo, one to set the direction that it's going to step, and then one to signal when to step. And you can switch those at any time. There are, of course, mechanical limitations. You can't step it, at 1,000,000 miles an hour or something, but it makes it very easy from a programming point of view to control. You can also get just a MOSFET driver chip that will just take the signals from 4 of the Galileo pins and amplify them using MOSFET drivers to have more power capability, and then wire the pairs of those pins to opposite ends of a coil. Then you have the option of setting both pins to a coil the same, which de-energizes it so it's not magnetic at all, or you can set it 1 and 0 and then it'll be a north magnet, or 0 and 1 and it'll be a south magnet. And by controlling those 4 pins carefully, you can make the stepper motor rotate. And there's actually, in the Arduino distribution, there's a stepper motor library that will do exactly that for you, so that you don't actually have to worry about how to sequence the magnets inside the stepper motor to make it step. You can just say, I want the stepper motor connected to these pins to take this many steps, or to turn at this speed, or to use this acceleration profile, if you use the more advanced stepper library called AcceloStep. And it's very convenient, and you can get a stepper motor running in 15 minutes or less, probably. The stepper motors I use are 200 steps per revolution, and I actually have a little gear on my spool, so the positioning on the string is like a 6,000th of an inch. And
so it's very precise, is what you're saying.
Yes, it's very precise.
Can you talk about how you get from an image or a series of lines and how it's going to draw to steps?
Sure. So I did a project before this, which was actually hooking up to an Etch-a-Sketch, which was much more straightforward. Every step of the one motor would move you horizontally 1 step, and every step of the other motor would move you vertically 1 step. Right. So then if you had X, Y coordinates, you could just draw a line between them by stepping them in the right sequence. And there's a very common algorithm called Breshingham's line algorithm that's, it's about 15 lines of code that draws lines given 2 XY coordinate pairs by deciding which steps to take. And it's normally used in computer graphics to decide which pixels to turn on, but it's equally applicable to stepper motors. And then I also Googled and downloaded a curve algorithm called Bezier curves, because I used CorelDRAW to export my my line art in EPS files, and then I extracted the move to, line to, and curve tos out of the EPS files, and that's what I feed into my code running in the Galileo, and it does the curves for me. It converts all the curves to a bunch of little line segments on the fly.
That's great. Now, and tonight we're really, I wanted to talk about the project you did, but we're also just generally talking about connectivity. How would you make this project a bit more like a connected project, or would you even do that in the first place?
Oh, absolutely. I would love to have gotten the Wi-Fi connectivity working for this demo tonight, but I kind of ran out of time. But that would allow me to use a web interface to pick which image I'm going to draw or to download new images to draw. And then I could let it be controlled from anywhere in the world, and it's all built, it's all the software's built into the Linux underlying the Arduino architecture in the Galileo. All you need to do is pop a Wi-Fi module into the backside in the micro PCIe port, or you can use the wired Ethernet port and connect to the internet that way. I also had dreams at one point about using Bluetooth to talk to small microcontrollers at the motors, so that I wouldn't actually have to have a communication wire running from the Galileo to the motors. I could do that wirelessly as well.
So that would use a Bluetooth PCIe, like a little PCIe card, like the Wi-Fi one?
Yeah, so the 6255 Intel card that fits in the Galileo, which is one of the options, there are lots of them, it actually has Bluetooth and dual band and Wi-Fi all built into one card, and the drivers are to support it are already built into the Linux image that Intel distributes. So it's makes it very easy. You just pop it in and go. The only thing that's a little tricky about it is the card is actually a half-size micro PCIe. It's really tiny, and so you have to get a little card extender, which you can get on eBay or Amazon, that makes it long enough to fit into the slot.
Yeah, and I've seen that they even have 3D printable extenders like this one.
Yeah, if you looked at the back of my board over here, you'd actually see I laser cut one when I was out of the scrap when I was cutting out the holder.
Right.
It's pretty straightforward.
That's great. I have to check out that. What was the model number again of that PCIe that has the Bluetooth built into it?
Let me get back to you on that in just a sec.
Okay.
I don't want to misquote the number.
Okay.
I think it's a 6250, but I'll check while someone else is talking and get back to you.
Yeah, sure. That's great. I did a project where I was using Bluetooth file transfer to talk to a Bluetooth photo printer, and I was able to, using another board, just like send images and have them print. I wonder if that Bluetooth chip will allow me to have Galileo connect to a photo printer, and I'm really looking forward to trying that out. So I want to try that PCIe board you're talking about.
Okay.
Michael, what have you been working on with Galileo?
Well, I've sort of an Arduino pedigree, and I'm sort of interested in teaching. So one of the first things you do when you're teaching beginner Arduino students is, of course, you teach them how to blink an LED, and you teach them how to push a button, and then at that point things are starting to turn in their minds, and I think the next step is what kind of thing could I build that's kind of fun, that uses these very basic concepts. So I actually have constructed a number of these little boxes which have buttons and LEDs built into them, and a little standard connector that you can put into your Arduino interface or into your Galileo interface. And we've made a little game where you run a little piece of software that waits an arbitrary amount of time between 2 and 7 seconds, and then it illuminates the LED, and as soon as you see the LED illuminate, you release the button, and in about 15 lines of code, you've been able to measure your reaction time. You can see how quickly you can react to the illumination of the LED. So another thing I'm interested in is fine-tuning design. I don't like to have a project that's just a breadboard and call that finished. So
Right.
I've gotten into kind of laser cutting. So what I have is this little deluxe version of the reaction timer box. You can see that it has
Looks great.
a nice little laser cut black acrylic top. It's got a little display that tells you how many milliseconds this guy took to release his button. It's a competitive version. It kind of like suggests an arcade kind of console thing. And then once you've built that, well, let's hook that up to a serial console and show the world that you're like an arcade game. What your score is? How many milliseconds can I beat Clay over here by in my reaction timer? And if we're talking about communication, I guess my eventual goal is to build several of these and place them around the world and use the Wi-Fi in a way similar to what Clay was describing. Upload scores to a database somewhere where you can look at results and see how you compare with other people around the world. And one terrific little unexpected outcome of this project is I've discovered that my reaction times are faster than my 16-year-old son's, and it drives him nuts, and it makes me really happy that I'm 51 years old and can still, I guess it's all that Donkey Kong I played when I was a kid, but my reaction times are a lot faster than his. So it's a project that involves pedagogy. I'm helping people do very basic stuff that's kind of easy to get off the ground with, and yet it's got a little component that's fun too.
Sure, and I like that because it's one of the first things you learn about is digital input and output, and you've got the input, the buttons, the output, the LEDs. That's great. And are you measuring the reaction time, I guess, in milliseconds?
That's right. I've learned that if you get practice, you can get reaction times that are under 200 milliseconds. I've gotten a couple under 160 milliseconds, a couple of times under 150, and it's a practicable skill. I didn't know. I get better with age. It's I'm a lazy person too, so I want to get the maximum bang for my buck, and it's really easy to take a button, take an LED, put them together, and write a little bit of software, and then suddenly you've got something that's it's kind of fun.
Yeah, I was visiting the Exploratorium a couple weeks ago, and they have a similar game where there's the typical reaction time thing, and then there is a sort of do the opposite. Like it says, like there's maybe a red button and a green button. Have any of you seen this? And it says like hit the red button, and you have to do it pretty fast. But then the second challenge is to do the opposite of what it says, and you can see your reaction time really drop because you've got to think, okay, you do the opposite. It's a really cool interactive and a lot of fun, and based on that same idea. And it's neat that like anyone could just take these tools off the shelf and build something similar.
Exactly.
Great. And Tyler, what have you been working on with Galileo?
So I started off really basic, just getting it working. I was really focused on getting the Ethernet and Wi-Fi working. I had a bunch of Arduino projects that are basically Internet enabled. But I did it back before the Wi-Fi shields really existed, so it was a serial Ethernet device talking to an XB to transmit to my Arduino device somewhere else that's run by XB.
Can you explain what XB is for the people who may not have heard of it?
Sure. So there's tiny little, they're basically RF frequency chips.
I might have one here. Hold on. I do. Okay. I'll show it to the camera while you talk.
So that tiny chip there speaks a protocol called Zigbee, and it allows you to transmit short distances, serial link. So you can send a character, and assuming there's no interference, it comes out on the other end. So you can use them to, what I was doing was making two Arduinos talk to each other. And on one side, I had a LAN connection. On the other side, I had my wireless device. At the time, it was much cheaper to do than buy a Wi-Fi device for the Arduino. But the great thing about the Galileo is it's got all this connectivity built on. So I don't need that second Arduino anymore to do the translation. I can move my project, my Internet-enabled lamp, over to running off an Intel Galileo board and remove a bunch of the code that was necessary to make that work, because now I can go and fetch things from the internet. Like the lamp is triggered by weather right now, so it'll go out to Weather Underground, fetch the current weather, parse the file it gets back, and change the color of the lamp. And the nice part about it is then you just have one plug going into the wall, everything's hidden in the lamp, and people don't really realize what it's actually doing, which is a neat effect.
Yeah, it's like the magic of the Internet of Things when you don't
Yeah.
even see the stuff going on inside. Now, how are you when you go to Weather Underground to get the information about the weather? How does the information come from Weather Underground, and how do you work with it using the Galileo?
So they have an API, and weather.com has one too, that you can basically retrieve a web page, and some give you back an XML document, which is like formatted text with tags around it, kind of like HTML. Other ones will give you back something called JSON, which is basically a compilable JavaScript object, but you can pull data out of it. So before, I was tearing it apart inside the Arduino sketch, and I'd actually have code that would find the exact part that I wanted. But the great thing with the Galileo, when I was moving the project over, was so I can use built-in libraries and programs on the Linux side from the Arduino sketch using the system command. So I can now use system, and then there's a wget command, which fetches a file from a web server. And I can fetch these files from Weather Underground or weather.com, and it pulls them onto the device. And so I can then use another command and actually tear that file apart using regular expressions, which are just a way to parse text files, basically. So all that functionality then gets moved outside of my Arduino sketch, really simplifying things, all because of the functionality that the Arduino has, that the Galileo has.
You could also call into the Perl library to parse either the XML or the JSON and have it, have it do the heavy lifting there.
Yeah, absolutely.
So, the part number, I put it on the chat. I don't know if the chat goes to everyone, but it's a 6235 Intel Centrino Advanced Bluetooth Wi-Fi adapter.
Great. Thank you. You mentioned, Tyler, the system function in Arduino code. Can you? I discovered it when I was first working with Arduino, and I got really excited about it. Can you talk about what this function is all about?
Sure. So with the Galileo, it lets you call a program or something else outside of the Arduino sandbox environment. In this case, on the Galileo, it lets you run commands actually from the Linux distribution that's running. So you can do things like start a telnet session or a telnet server, or bring up the Ethernet interface right from there. So you can control that right over the Arduino interface. The other benefit, though, is that when you run commands, you can do things like the wget, which puts a file right on the actual Linux image that you can then read from within the Arduino interface.
So the system function is like a bridge to Linux land within Arduino code. So people who are using the Arduino IDE can still access the power of Linux without having to get into it too much, right? I mean, depending on like what you want to do, right?
Yep, exactly.
Have Clay or Michael, have you been using the system function at all to access the Linux side of things?
Yeah, in fact, the first thing I did, remember I told you I was lazy a little while ago. I'm too lazy to go buy a serial cable. I'm too lazy to figure out how to plug an Ethernet port in, but I still want to talk to the Linux underpinnings. So the first sketch I wrote on Galileo was just a little sketch that captures commands from the Arduino serial console, routes them to serial, and routes the output. Routes them to the system command, and then routes the output from the system command back out through the serial console. So it's what I call it is a poor man's telnet. You're typing commands into the Arduino serial console and seeing the output on the serial console.
That's handy.
It's really powerful that you can basically anything you could type in a Linux command prompt, you can send to that to that system command, and it'll run it for you.
Yeah, I think one of the first things that I did was when I plugged the Galileo into my Ethernet port, and this is a common thing with a lot of boards I get where it's like, plug it into my network, what's the IP address? I have no idea. And so I made a quick Arduino sketch that uses the system command to run the Linux command, what is it, ifconfig, which when you run that on Linux, it spits out all the information about all the connections, and so that came back through my Arduino serial thing, and then there's the IP. And then I was able to connect to the Galileo over my network, because that was a common problem that I had with other boards and other devices I was using. I'd plug them in my internet and I'd be like, what is this device? Yeah. So there's a question that I don't know if any of you guys are going to be able to answer this, but this is coming in from Ayan in the chat. He says, is it possible to configure MATLAB Simulink with Galileo? Are any of you familiar with that software? I'm not.
No.
I actually have used Simulink with the Arduino, and as long as the Galileo will read the Arduino libraries, which it does, you can actually hook Simulink up to it.
Oh, that's great. Okay.
I would say that the processor on the Galileo certainly has the horsepower to run those things. I don't know if they're available for the particular distributions of Linux that are supported, though.
Right. Okay, thanks. I wanted to point out another thing that we had talked about this in the last Maker session. On the Galileo, there is this port on it that looks like an audio port. It looks like a headphone jack, but it's not. It's a serial port. And we talked about using that, and I wanted to show you guys what I used to do that. Here is what looks just like a regular audio jack. It has this sort of old DB9 connector, and then I can take that connector, connect it to this one, which has a USB port on it. And what that allows me to do is to connect over serial to Galileo, so that I can get to the command line that way as well. I have a program. There's actually a program out there that's free and cross-platform called CoolTerm. I don't know. Do any of you guys use CoolTerm or Putty maybe?
Putty.
Yeah. So I can connect via serial, and I get to the Linux command line if I want to write anything there, or I want to test a command out that, like for me, if there's a command I want to do through Arduino using the system call, I'm going to try it, typing it in myself right into the command line first to see what the output is. So then I can go into my Arduino code and then see how I can kind of work with that output.
And one advantage, Matt, of that serial cable over, say, the Ethernet or the poor man's telnet like I was using is that if you're trying different Linux boot distributions, you can actually watch the boot up sequence before your Ethernet ever comes up or your Arduino ever comes up. So you can diagnose stuff that's going on very early in the boot process with that serial cable.
Absolutely. What else do you guys have in terms of plans or how you want to use Intel Galileo? Anyone?
So my next project is I'm a big barbecuer coming from Texas, and I'm building a unit that attaches to the side of my smoker and probes the meat temperature, and I want it to publish a web interface so I can look on my iPhone, see how my stuff's doing, adjust the temperature of the smoker and all of that, even when I'm out on the go, instead of actually having to go out and check it. I have the advantage of using an electric smoker, so it's a little harder if you have a wood smoker, because then you have to have something to push wood in. But yeah.
And as every good barbecuer knows, to get a good brisket, it's 12 hours of cooking. So you're likely to be out and about, right, when you're cooking that brisket.
At least 12.
Wow, I didn't realize it took that long to make brisket.
It doesn't take that long to make brisket. It takes that long to make good brisket.
Ah, that's the difference. Maybe I have not had good brisket yet. I'll have to, next time I'm in Austin.
Come on down, Matt.
We'll hook you up.
So when you talked about creating a web interface with Galileo, what kind of tools do you use to do something like that?
So there's a web server written in Java that's readily available and free that you can run on the Galileo. There's also JNode, which is probably also written in Java. I haven't actually used it, but that looks to be what's most popular out there in the community. And it's theoretically possible to run a full Apache web server on it.
Wow.
So you'd be tight on the memory, I think, at that point.
Right.
Matt, I have visions of making. There's a little company in Austin here that makes beautifully tuned wind chime tubes that sell from anywhere from $50 to $3,000, depending on how big they are. And I have this vision of ripping my doorbell out of the wall and making my own custom doorbell using a bunch of these custom tuned tubes and a Galileo sort of mounted inside the wall with Wi-Fi connectivity, so that I can ring the doorbell remotely if I want to, or I can program what happens when the person outside pushes the doorbell. I can configure my doorbell from afar. The idea of one of these little Galileos with its little Wi-Fi ears pointing up inside my wall behind where my old-fashioned doorbell used to be, that kind of appeals to me.
You could actually take that a step further and put a wireless webcam on it and do facial recognition using the libraries on the Galileo.
Yep.
And then you could have different door chimes for different people as they walked up.
Let's talk afterwards. I have that in mind too.
Uh-oh, I just ruined his $1 million idea. Sorry.
And is there any particular? You said you wanted to control it with your phone. Would you do that with a web server that's running on Galileo, or?
Yeah, I would probably run a web server on the Galileo, and then I could just browse to the right address, and Dine address or somebody like that will give me a handy name to get to my smoker. So I can pull up Clay's smoker at douglasonline.com and see what's cooking.
That's great. That's great. And Tyler, what about you?
So my hope is I have a bunch of these different devices that I'll use to connect this serial Wi-Fi, serial wireless link, and I'd like to move more of them over, but ideally I'd like to shift them totally away from the Arduino code and kind of get them running all from like Python on the Galileo or something. So there's that in mind, and then one of the other projects that I've been toying around with, I have like 4 iterations of, is a remote control garage door opener. So I leave home and I can't remember if I put my garage door down, and so I have a camera on it now, so I can see it, but then I just know it's open, and I know I could trigger it using the Galileo, and that would be much more helpful than to know, oh, I'm at work and my garage door is still open.
I'll buy one of those, Tyler.
It's a very popular thing to want to be able to do that, to see what's going on with the garage.
Yeah.
I'm sure like a lot of people would want that. My father, like I don't have a car myself, but I remember growing up, my father would, my mom would look at my dad. Did you close the garage door? He'd say, yeah, I think I did. He goes, my mom would say, did it bounce back up? There was some like mythical thing that might happen, that it might like bounce back up, and it was just always funny. It was a kind of a running joke in our family, because like it was always this moment like, is the garage door down? Oh no, we'd be like on our way to like a family vacation or something.
Yeah, there's a bunch of devices that get like halfway there, and there's some internet-enabled webcams that have relays and things, but they don't quite go all the way. And so this would be really tweakable, and I think a neat project to do, especially since it's got the Wi-Fi.
Now the guys over there in the Science Center, you guys use Arduino a lot. What kind of things is on deck for you guys with building and creating? Do you have an interactive that you have in mind for this?
Well, so there's a couple things. I've sort of spread the addiction to the other educators and the director of the Science Center, just with pies. He's like, I want to put a pie on everything, and he has no idea, really what it is. One of the things he wanted to do, we just put an actual real analog timer on it. You just want to turn it off and on. But they're interested in a lot of things. Either the interesting teaching moments, like the button and the LED example, was actually really powerful for folks, even though it's so simple. But then they also want to build it into, there's a startup and a shutdown sequence for the entire city. I mean, it's a huge building, and they are now starting to realize that they could do like what Clay was saying with his barbecue smoker, but instead it might be one of the exhibits that are here. And I know that the director just wants a big fancy dashboard, and he can go on. Or actually, I don't know if Exploratorium's doing this or not, see what exhibits are actually getting the most use through a number of sensors, and that's really valuable data, so we know, I don't know, this area of the center is not getting any traction, or maybe it's broken, or just boring. So I think it's powerful to hear you guys talk about the Linux underpinnings and that power, and because we've run up against even, there's a digital signage product that we use here that's free and open source, but it was too powerful, or maybe the Pi or BeagleBone didn't have enough for the right libraries. So I'm interested in seeing how it can be fun and a learning tool, but really help streamline the day-to-day operations. It's really wonderful.
That's great to hear that not only could it be used for just interactive, but also just the day-to-day. That's fantastic.
I think people can see the possibilities even though they don't fully understand it. I mean, that's why I have Hal here. I just made the LED blink. So,
Baby steps.
baby steps, yeah.
Yeah. And how no, go ahead. Go ahead, Michael.
I was just going to say, Luis, you make an interesting point about let's put up some sensors here. I think what's so beautiful when you're a teacher is that eureka moment when you say, okay, here's a device that can control these 250 different kinds of output devices, and it can take input from these 250 different kind of sensors. Now, let your brain start going and see what you can come up with, and it's amazing when people start going from reaction timers to all the stuff we've been talking about. I think we're just at the beginning of a big revolution that's going to be very interesting over the next few years.
When we were putting together some training material that Michael and I worked on together, one of the projects he wanted us to include was a light sensor that moves a servo, and basically you put a chopstick on the servo so it looks kind of like a needle on a meter, and then as you move your hand nearer and further from the Galileo, the little servo moves, and I kind of wrote it off as just something to do, but after I built it, it was actually remarkably fun to play with, and you get that interaction, and the Galileo brings the ease of getting things started with the Arduino, and lets you play with simple things like that in very short periods of time, 15 minutes or something, and then underneath it has all this power, and as the libraries, you can tap these libraries that'll do facial recognition and image capture and TCP/IP communication and all this stuff, web services, and all that power is right there. So once you get people started playing with the simple stuff, then they start wanting to use the power, and it's got a lot of potential, I think.
We're really in a playground for the first time in my life anyway, where the limit is, for the first time, is really your imagination. If you don't make something cool, it's just because it's a failure of your imagination, and that puts a lot of pressure on you.
It can be stifling. Yeah, when you have something that has so many capabilities, and this is with any board at all, and you start realizing what it can do, you freeze there. It's like, what do I want to do first? Or sometimes it's just like you need to just focus on a single capability of a particular board or a particular function of a technology you're using, and saying, okay, how am I going to use this, or how can I use that? And it helps focus a little bit. If there's people out there who are struggling with getting ideas together, I think that's one way for me that's been helpful, is really focusing on a particular technology and what it affords in a project, and exploring that by making over and over again. Even if you do put a chopstick on a servo and you're seeing the needle going back and forth, it's that working and doing that really inspires, and it triggers ideas. Some of my favorite projects, the projects that I'm most proud of, came from just trying little things out like that, and saying, I don't know what this is going to do, but let me try it out.
Yep. Well said.
What about you guys in terms of I'm sure there are people out there who do struggle with creative, there's the creative struggle as well when you're a maker. Is there a way that you guys work through that?
I have a funny technique. I go to bed a half hour earlier than my exhaustion level tells me I need to, and as I'm lying in bed falling asleep, that's when, without fail, my ideas come. I don't always remember them in the morning, of course, but that's my strategy, and it's a real strategy, Matt, to combat that creativity barrier you're talking about. Is I go to bed and I think about stuff while I'm falling asleep.
Yeah, at least for me, I find that trying to think of something is the worst thing you can do, because it'll come to you when you're doing the dishes, or you see a dog bolt by, and it'll be like a bolt out of the blue. It really, but you have to ruminate a little bit on the technology, and then when it starts to fade out of your brain a little bit, something comes through and triggers.
I'm a big fan of collaboration. I'm sorry.
I was going to say, now, we're kind of lucky that we live in the age that we do. I mean, you've got a phone in your pocket that constantly you can record. anytime that you come up with an idea now, you can just jot it down and or even just record it on your phone. For me at least, I find that it's always early morning. I'll wake up at 2 or 3 in the morning and have this wonderful idea, and if I don't record it right then on the phone, I'll never remember. And even if I do record it, half the time I can't figure out how to bring it to fruition anyway.
It was the excitement of the idea that woke you up at 2 in the morning?
Exactly.
Wow.
I'm a big fan of collaboration. When I have a project that I'm working on and I'm kind of not seeing the next steps, I like to get together with other people in the maker community and talk to them about it and bounce ideas off of them, and I find that's really a good way to move my projects forward.
Absolutely. The grad school where I graduated from and I'm a research fellow at now, it's called ITP, and the main core kernel of the whole program is creative collaboration and bringing people from different backgrounds together and seeing how how they work together. And the whole space that the school is in is based around collaboration. It's big open space, big tables where you can sit and talk to people. People work out in the open so that if you're walking by someone and let's say they're working on a drawing bot and you just start to say, hey, that's a cool draw bot you got there. Like what's going on there? And you start talking. You say, hey, I saw this other thing. It's amazing to see how when you've got this thing that I call a mixing chamber, how ideas can kind of organically grow when these people and ideas are bouncing around. And I've been kind of like playing with this idea of mixing chamber and how we can either take our own ideas, put them into a chamber and shake them up, or mix with other people and get ideas moving around like that.
Yeah, while I was working on the drawbot out here in the main work area at Tech Shop, there were a lot of people stopping by and looking at it. And I have this one guy who's desperate for me to build a big version of it that holds cans of spray paint because he wants to do large format graffiti.
Well, there you go. There you go.
Speaking of that, can we see the drawbot draw in the background while we're chatting?
Sure.
Yeah, that would be great. That's great. So we have some questions. Maybe, Michael, you might be able to answer this. There's one from Bob, and he's asking about other Linux distributions. Is it possible to run other Linux distributions?
You know, I'm not directly able to answer that because my pedigree, as I said, is from the Arduino side. But I was reading on the forums today that it is possible to do that, and a lot of people are trying. I think there's some difficulties that people are encountering. I see I'm out of the picture here, but that's okay.
There you are.
In theory, yes, you can do that, and there are some benefits to getting different distributions. I don't have direct experience, so maybe someone else can answer.
I know I saw a forum post 2 or 3 days ago. I was reading through that they were talking about they had gone through and were building their own base distribution to run on the Galileo, and they were coming at it from using an unsupported Wi-Fi card, and so they started from total scratch and built everything up, and then built the drivers to support that Wi-Fi card on their kernel.
Yeah, there's a tool called Yocto. Have any of you heard of that?
So yeah, that's the Linux distribution that Intel ships with it. I know there are also Debian distributions, which is a pretty popular one, and I've seen mention of others, but I've not actually used any of the others.
Yeah. So Yocto is not a tool, but it's a distribution.
As I understand it, the Linux is not my deep specialty here.
Right. There's another question that came through the Google Plus community, and it's from Xiao asking, can you use a webcam to snap pics or do face recognition? We were talking about that before. It's quite possible, I would say, with OpenCV perhaps.
People are doing it already.
Is OpenCV still the best solution for something like that? Are you guys familiar with that?
I am familiar with it. I have not used it very much. I did a Halloween project last year where when people walked down the hallway, it would find the people and it would trim them out and superimpose a monster walking up behind them. And then we had a big TV at the end of the hallway so they could see themselves walking down, and then when they turned around, we'd trigger a big burst of cold air. And we used OpenCV for that, and it worked like a charm. We had some other issues, but that part worked like a charm. And people are using OpenCV on Galileo. I've seen lots of posts about it, and people are excited about.
That's great. Now, I've used OpenCV a little bit, and I've only figured out how to do face recognition, but not like identification. So it would say, okay, yes, there's a face in the frame, but can it do you guys know about if it's possible to actually like say, okay, this is a face and it's Clay's face?
I don't know if OpenCV does that or not.
Mm-hmm. Okay.
I'd like that facility too, Matt. I want my wind chime, Galileo wind chime driver to play a different tune based on how attractive the person is who comes up near it.
Measuring attractiveness may be a little harder than just facial recognition.
I'm sure there's someone working on that somewhere. All right, so is there anything else I mean, we're just kind of shooting the breeze here. Is there anything else you guys, any questions you have, anything you want to throw out there about Intel Galileo, anything else you want to talk about?
Google yielded the answer that there is a face recognizer library for OpenCV 2.4.
Okay, and that's I guess my question is that's distinct from yes or no. There's a face in frame versus this person's face.
It recognizes gender, and it can look people up in a database and say how closely this face matches people out of the database. That's
incredible. Imagine that.
If I can identify gender, I'm halfway to attractiveness.
All right, we're going to see that wind chime. All right, guys. Thank you so much to all of you who came here. Thank you to everybody who was joining us and watching. If you are watching this recorded, you can still go to the Google Plus community and put questions there. Our master makers will be there, and also all the other teams are working together. And I'm in the Google Plus community asking questions and putting answers where I can as well. So please feel free to use the community to get help with your projects. I also would love to see what you guys are working on, even if it's just in progress. Put a post in the Google Plus community, throw up a quick photo. We want to see what you guys are doing with your Galileo boards out there. And next week, next Thursday night, we're going to have a show and tell of what you guys worked on. It doesn't have to be a finished project by any stretch of the imagination. Even if you just got a blinking LED going, we'd love to see it, and we'd love to talk about it. So post those pictures in the Google Plus community. I'm going to be watching there for all kinds of activity, and I'll be also recruiting people to join us for the Hangout for the show and tell next week. So thank you to Clay, Hal, Luis, Michael, and Tyler for joining us tonight. I really appreciate it. You guys, I hope you'll jump into the Google Plus community as well and continue the conversation there as well.
Thank you, Matt. It was fun.
Thank you.
Yep. Thank you.
Thank you. Have a good night, everybody, and we'll see you next week. Bye.
Bye-bye.